Problem 75. Two airplanes left the same airport traveling in opposite directions. If one plane averages 400 miles per hour, so let's see, this is the airport. One plane goes in that direction at 400 miles per hour. That's a mile, not a meter. And the other plane averages 250 miles per hour. It's going the other direction, so it's going at 250. And I do this as vectors, so it kind of the length of my arrow represents its speed to some degree, and the direction represents the direction. 250 miles per hour in that direction, 400 miles per hour in that direction. In how many hours will the distance between the two planes be 1625 miles? So you just have to say, if you're sitting in this plane right here, this plane is the left, and you don't know, let's say you think you're stationary. How fast is that plane going to be moving to the rightwards direction, or I guess in the eastward direction? Well, from your point of view, it's going to be going in the east direction at 650 miles per hour, right? If you thought that you were stationary, it'd just be going away from you at 650 miles per hour. 650 miles per hour, right? Same thing. If you were sitting in this plane right here, and you thought you were stationary, and you are relative to yourself, you'd say, oh, why, this guy is going to the west at 650 miles per hour relative to me, and we're starting at the same point. So this just becomes a standard distance is equal to rate times time problem. So if we have to cover 1625 miles, because that's what they want to know, when does that happen? At what point are the planes that far from each other? That is equal to their relative velocity. They're separating from each other at 650 miles per hour. And we want to know how long that's going to take. So time is going to equal 1625 divided by 650. See if we can simplify that at all. Well, we could divide the top and the bottom by 25, right? If we divide the top one, well, let me just get my calculator. So 1625 divided by 650 is equal to 2.5. So time, and we were doing everything in miles per hour, so time is going to be equal to 2.5 hours. That's choice A. Problem 76. I should copy and paste all of these word problems. We'll parse them together. Problem 76. In green. Green. Lisa will make punch that is 25% fruit by adding pure fruit juice to a 2-liter mixture that is 10% pure fruit juice. Okay. How many liters of pure fruit juice does she need to add? Pure fruit juice. So let P is equal to liters of pure. And that's what they want us to figure out. So we have to figure out P. All right. And let's say that adding to a 2-liter mixture. So let's say M is equal to the liter of mixture. Liters of the mixture. That is 10% fruit juice, right? So that is this right here. To a 2-liter mixture that is 10% fruit juice. We're calling that M. That is the 2-liter mixture that is 10% fruit juice. Okay, how many liters of pure fruit juice does she need to add? Okay, so let's think about it a little bit. So the total amount of, she's going to add a punch. So she's going to add punch. So punch is going to be pure juice, right? So let's think about how much pure juice is going to be in the system, right? The liters of pure juice she adds, plus the liters of the mixture. Well, it's a 2-liter mixture that is 10% fruit juice. So how much fruit juice is already there? So it's 0.2 liters of fruit juice, right? It's a 2-liter mixture. Oh, you know what? I shouldn't even define M. We know that M is equal to 2. So ignore that. Now, you can tell I'm doing these problems in real time. I'm struggling with them as you would. Anyway, so how much fruit juice is there going to be in the mixture? There's the amount of liters of the pure fruit juice she adds. And then, this is a pure fruit juice, that's P. And then you're going to have the 2 liters of the mixture that is 10% fruit juice. So how much fruit juice is coming from that? Well, 10% of 2 liters is 0.2 liters already. And then how many liters is there going to be in the mixture? In the combined, how many total liters are there? Well, there's the liters of the pure fruit juice plus the 2 liters that we're adding to, right? This is the amount of P this is the amount of fruit juice. This is the total amount of liquid, right? And we got the 0.2 from 10% times 2. And we said that this has to equal 25%. We want this to be 25% of this, so this should be 0.25. That was an inadvertent mark right down there. So now we just solve for p. Now we just solve for p. The hard part is setting up the problem. See, p, so let's multiply p plus 2 times both sides. So you get p plus 0.2 is equal to 0.25 times this, so 0.25 p plus 0.25 times 2 is 0.5. Fair enough. Let's subtract 0.2 from both sides. You get p is equal to 0.25 p. 0.5 minus 0.2 is plus 0.3. Let's subtract 0.25p from both sides. 1p minus 0.25p is 0.75p is equal to 0.3. And let's see where this goes. Did I do that right? 0.75p is equal to 0.3, right? Okay. And then you have, let's see, you get p. So the decimals sometimes get confusing. Let's multiply both sides of this equation by 10. You get 7.5p is equal to 0.3. Sorry, is equal to 3. We multiplied by 10. So you get p is equal to 3 over 7.5. How many times does 7.5 go into 3? So that's the same thing. How many times does 75 go into 30? Put a decimal sign. Let's see, it goes into it, I think 4 times, right? 4 times 5 is 20, 30, right? 4 times. So it's 0.4. So P is equal to 0.4 liters. We have to add 0.4 liters of fruit juice, of pure fruit juice, to the 2-liter mixture. So you add 0.4 to the 2-liter mixture, so you end up with 0.6 liters of pure fruit juice. So the numerator becomes 0.6, and the denominator becomes, yeah, this was 0.4, this becomes 2.4, which sure enough is 1/4 or 25%. Fascinating problem. Next question. And these are good to learn. You know, a lot of times in math class, people are like, oh, you know, what do I need to learn this for? But this type of algebra, you're going to use it all the time, especially if you go into any type of science or engineering, or for that matter, investing or finance. You're going to use these kind of, you know, boy, can I figure this out or not type of equations all the time when you're mixing things and figuring out margins and all the rest. Okay, let's see. Which relation is a function? So we'll have a little bit of review of a function. So a function is a relation that maps from a domain to a range. And I haven't looked at these yet, but the catch here is, oh, I want to say from A to B, or we could say from the domain to the range, right? Where it takes one set of numbers, which we call the domain, and we have another set of numbers, and for every number here, there's exactly one number in the range, right? And that's a key. There's only from here to here, there's only one number. Now, 2 of these could meet the same number, but you can't have one number here going to 2 separate numbers there. That's the key. So what we probably want to look for, let's see. Here we have the same number. So this, let me get a better color. So you have a -2 here, and you have a -2 here. So that's like the same number. You have let's say this is a -2. That -2 is going to a 6. It's going to a 6, and here it's going to a -2. So you have the same number going to 2 different numbers, and you can't have that in a function. For any given number in the domain, you definitely get only one in the range. So A is not the answer. Let's see, does this have that same problem? See, every number is there exactly once. You have 1 -2, 1 0, 1 1, 1 2. So you're not going to have that problem. My suspicion is it's already B. See, yeah, you see, C has the same problem. Number 4, for every 4 goes to a bunch of different numbers. 4 goes to 0, 4 goes to 1, 4, so it's not C. And then this defines 2 values for 10. So that doesn't work either. So the answer is B. B. Problem 78. 78. All right. This is, okay, let me. For which equation graphed below are all the y values negative? So if all the y values are negative, we have to stay below the x-axis, right? This is where all the y values are negative, right there. So this one seems to work. A seems to work, right? Here, these aren't negative y values. These are positive y values. Oh, I didn't even copy and paste all of these, but I can already see what, look, these are positive y values. These are positive y values. So A was the answer. I'm sorry, I ran out of space. Anyway, I'll see you in the next video, right? All of these y values are all negative. You're staying in the third and fourth quadrant. All right, next video.